The digital security program is basically changing the way computers work. This hasn't happened for decades, 50 years. So what we're doing is actually changing how today's computers work. It's a fundamental change, and it will bring significant benefit to everybody who is dependent and uses computers.
The digital world that we live in was not designed with security in mind. What's happened instead is lots of the technologies have been patched, they've been iteratively developed, but the security has not kept pace with all of the different ways that we use technology, whether it's for banking, for commercial, for work. And so what digital security by design is doing is effectively starting from a clean slate, rebuilding the foundations of our digital economy to make it secure by design.
So back in 2019, the UK government, as part of their industrial strategy, asked UK industry, what is it that you can't solve yourself that you think there's a big social or economic problem for the country with? And a consortium of companies proposed that this concept of digital security is such one of those to overcome. So the government provided £70 million of funding that was backed by over 100 million, nearly 200 million of co-investment from other partners in that ecosystem to basically try to kickstart and bring a collaboration of companies and academics together to actually address this problem.
So a lot of companies have to spend a lot of time and money patching up security when it goes wrong. And what we're trying to do is design that into the hardware so that in future 70% of the things that we patch up now might be prevented in the first place.
Cherry is a new way of designing computer hardware that addresses two problems. The first of these is to reinforce the structure of software so that it's less fragile, it's more resilient to attacks. And the second is to allow you to compartmentalize software. That means that when there is a successful attack, the attacker gains as little as possible.
ARM has spent a lot of time working with Cambridge University. We've taken some of their Cherry architecture and developed a prototype architecture which we call Morello. And we've now taken that over the last 2.5 years. We've been building and designing that into a system on a chip. And now the system on the chip is ready and it's in production and it's made, and we're distributing those on boards called the Morello board as a demonstrator for this DSBD project. And we're now at a really exciting phase of this project where we are distributing those boards to partners to come and play with them and use them and test them and run some of the exciting projects. So we're really at the start of the phase where everybody is investigating, does this technology work? How does it work? What can we use it for? How will it help us in the future?
ARM's Morello is the first industrial quality implementation of Cherry, and it is the thing that we need to help demonstrate to the world that Cherry will help solve these problems.
So the program's in about year 3 of a 5-year program. We're at the stage where we have the technology prototype, so we have lots of partners now receiving the actual first piece of hardware. They're trying their solutions on it, they're evaluating it for the business. And we've really got another 2 years now for those programs to run. We've got probably around 200 participants directly funded within the program.
In order to bring everyone together, we've got some really big industrial partners. So we have ARM, who are building Morello, we have Microsoft, we have Google. So we have the big industry organizations. Although it's an engineering program, effectively, we're building a technology. We can't do the field of dreams, if you build it, they will come, because that's not how adoption happens. So a large part of the work of the social scientists and of the economists is to try and move away from just building and hope, but instead trying to design for a large-scale adoption of this new technology.
From our perspective, the only way we're going to get people to take up technology is if they trust it. And having secure by design and secure infrastructure and secure hardware is a core component of that.
Imagine a world where we're not worried about securing our information, our technologies against vulnerabilities that we know exist and we're constantly having to deal with. The potential to then have entirely new ways of designing, of engaging, of building within the digital economy, because we're less worried about constantly securing things, but instead we're able to do so in a trusted, safe, secure environment, could be enormous.